So there is a new version of the textbook that has just a minor addition to the textbook. It just gives a little extra, a couple programs dealing with character arrays. And so we'll go over that today because we're finishing up arrays and we're going to start structs. So a special kind of array is a character array instead of an integer array, say, or array of different types. And so here's a program. Let's look at it. So we have an array here. So this is an array with 7 entries, and each entry has to be a char. Now, letters is implicitly, because it's an array, it's a name. So letters is actually a variable that holds the address of the C here. Okay, and you can see there's 1, 2, 3, 4, 5, 6, 7. And you can see you put characters inside single quotes. You only put one letter in there. Whereas the next line 7 is a special syntax for a string, what's called a string, because a string is a sequence of characters like that's on a like beads on a string on a necklace or something, and like those little beads that have a letter on it. You can think of it that way. And so name is explicitly the see, it's a pointer to a character. So name is the name of this. Name holds the address of the C. You can't have an address of the whole thing because it's just the address of the C, and letters is the address of the C. And so you have a character array and a string. Now, the extra thing about a string is there's a hidden 0 at the end, right? This is not a string because there's no 0 at the end. A string is something you can send to printf. So here, printf, you take %s as a formatting code. Like if you put D here, you'd have to put an integer here, but S means you're going to format this as a string. Now, if you put letters in here, it wouldn't know where to end. So it might print, it depends what comes on the memory cell after this. That might be a 0, or it might be some other number, or it might be a printable character. So you could put it in, it could cause some kind of programming error, like reading from memory that you're not allowed to read from. Okay, so this should print off the name Carlos. And then now one difference between a string and a character array is, although the variables name and letters are local here, the string, these are special initializers, right? For the string, you can put the piece of text in double quotes. So what this compiler is going to do is make this into a sequence of ASCII codes with a 0 at the end. And so the implementation of these two will be the same, except there'll be a 0 here. So this is just a convenience initializer so that you don't have to go through a for loop. But it's just you can only put this curly brace initializer for an array on the line that you declare the array. So there's some limitations. Now, the difference between the array here with letters and name, one difference is this is not writable. I can read the individual letters here, but I can't write to them because it's the string Carlos is going to be saved in a read-only part of memory. Whereas these variables are going to be writable. So I could just change the letters here. So that's another difference. And this illustrates this. So with letters, I'm going to replace the exclamation point at the end with the number 0. Now, if I put a 0 in here, I just get the character 0, which would be like x30. I need the number 0. /0 is the character that has all zeros. Now, I could put a 0 in here without the single quotes, but then I would get an int that would be like 64 bits or 32 bits, whereas a char is only 1 byte. 8 bits. So that would put some zeros in that you don't need to put in. So it's better to just keep the type. This is this is the name of a character, and here's a character. Meaning it's just the only thing with types in C is the number of bits. A char is just a number with 8 bits. It's used for a character, but there's nothing special about it. It's just a number. It's just a byte. Okay, so here, since I put a 0 here, that converts letters into a string, so I can then use print off this, and these should be identical, right? So I should have up here Carlos, 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 and then here, see the formatting string here is C for character. So it's going to go into name 0, 1, 2. So this should print an R because it's name plus 2. And then it gets what's pointed to by this address should be the R. And this is letters plus 3. So this should be the L, because the letters plus 3 is the address of the L, and the star dereferences that address that sort of shoots through it and gets the L. Okay. So I have, let's make sure this is saved. Let's see if we can GCC arrays ch.c. The output file is arrays ch, and there's no errors because I fixed them. There were some errors but when I wrote the program, but I fixed them. Okay, so then we can run the program by saying in the current directory, array ch. And so this first one here prints Carlos. Then this was the string. Then here you print the string again and the character array, because you put a 0 at the end. And then this gets name plus 2, which is the R, and this gets letters plus 3, which is the L. So you can also put zeros in the middle. Like I could put a 0 in letters at 0, 1, 2, 3. If we can modify that and do this. We can do letters square bracket 3, because that would be 0, 1, 2, 3 equals 0. So that makes just the first 3 letters into a string. And then the last letters, OS, is also a string. And it doesn't make any we could also, let me see, why not do letters square bracket 0, 1, 2, 3, 4, 5. That's the S. 5 equals of. Okay, and then we can print what do you want to do? We want to do letters, because that should print off car, and then we want to print off %s, and let's put a new line, and then we want to do %s again, 2 strings, because we actually have 2 strings now, CAR and OF, and we can put for the first one letters, and the second one letters 0, 1, 2, 3, 4, zeros plus 4. Now the string takes an address, unlike C, which takes a character. So I haven't tried this before, so let's see if this works. Okay, didn't mind that. Okay, so here you see the same as before. We haven't changed that, but here's the effect. We see we have car, which was the first string in this array, and then OF, because we changed the S to an F, and then it's also a string because we started it at the O, right? Like that. So I have two strings in the array now because I put a 0 in, I put zeros to divide the character array into two strings. Well, you had some exercises like this when we did assembly language, where I take a string and try to put a 0 in the middle to try to confuse you as to so you'd sort of have to figure out, see what was going on at a low level. So this is doing the same thing at the level of C, which you can see that with the C language, you have fine control of the memory cells. Now, in Java, you also have something called strings, but strings are pieces of text like this. And in Java, you would do something like, instead of this, you would do string name equals new string. Carlos. Now, you actually wouldn't do that because, well, you could do it. That's what's actually going on, is that you have a reference variable name that's being implemented by something like this, and you've made a new object of type string this is calling a constructor, like with one argument. But what you actually do would be something like name equals Carlos, like that. And this is a convenience that sort of matches the way C works. But what your Java compiler will do will put in the constructor itself. It's going to create a string object using this as the argument to the constructor. So a string in Java is a object that manages a field variable that is an array of characters, but it has lots of methods associated with it, whereas a string in C is just a pointer to a character, right? So it doesn't know it's not an object because there are no objects. Now, all those methods that were in the string class, they're also present more or less in the C language. There's a header file that I think may show us this methods in C. These are all functions in C for copying, comparing, setting. These are string copy. There are string length, there's substrings, there's string tokenizers, there's formatting. So basically, there's a whole raft of string methods here. Some subset of them have been renamed and appear as methods in your string class in Java, because the object-oriented idea is you put the functions that deal with data together with the data, right? So, but you still have all the same tools that you would use as functions in C. Like if you look at input output, if you do this, this is the manual. MAN stands for manual pages. This is a file, and so this is the manual page for header file, which lists all the functions. You can also do the one that you have done before, like this. And it does, it has a lot of constants, and somewhere on here, there's going to be a list of functions. Like down here, there's a whole bunch of stuff dealing with files, with characters, with reading and writing, scanf. There's printf in here. So there's a huge number of input output functions and all kinds of stuff. Okay, so that's where you these are like these then would be in I think a system.io class, right? Because in Java, you also, for example, in Java, you also have a printf statement. You have system.out.printf, and it has some of the same syntax that you would do for C. And in fact, this is like you might have been using print line or something like that, which is like a defective version of printf. Printf allows you to format things very concisely using this nice syntax. And there was, I think, a programming competition a few years ago by students at Mass Bay, and they didn't know about, they were doing it in Java, and other schools were doing their stuff in like C because they were all text-based input-output, or if they used Java, they knew about printf. And so the first problem involved printing out numbers in a certain format. And it's really simple to do with printf, but it took the Mass Bay team like 30 minutes to figure out how to print off a double number with only two numerals, like 5.63 instead of like with no extra numbers after the decimal point. So printf is really a good thing to know about even in Java. Okay, so that's basically what I wanted to say. Let me see, is there anything else? Oh, yes, there's one thing. You have, when you you have arrays of, what if you wanted an array of strings, right? If you wanted to have, like, for example, in Java, you have your incantation, that starts off something like this, right? That's your Java incantation for the main method. So here you have an array of strings, right, which is the arguments. Now you never use this very often because you're usually using Java for a GUI interface, unfortunately, and so you don't see that. So yeah, this goes back with the fact that the main method occurs in the class. That's how you start a Java program. The main method is where the main function is where you start a C program. But you can see the main function in C has a return type of int because its native environment is the shell for systems programming when you're using it on a terminal. So you're using a shell to manage the running, whereas Java, that's not the main. You're to use this in a virtual machine, so there's no point in having a return type of int. So you have void here. But what about this string args? Well, that's actually important in C, and you can do that with the same way with int arg C, and then you have to do char, and you can do now a character array in two ways. One is args like this, right? Because you can say this sort of matches up in which this is sort of like a declaration of saying that args is an array of characters, right? But this isn't going to quite get it, right? Because this is going to be an array of characters, but you want an array of strings. So you have to put that in there. That's option one. There's another option, which is int main int arg C char star star args, right? Because what is an array of characters? Well, let's do the second one. This is the one that sort of makes more sense. It's saying char star is something that points to a string. This is an array of things that point to strings. It's an array of pointers. The array is actually an array of addresses, because there'll be like the address of the first string, the address of the second string. And so each of those addresses will be something that points to that points to a char. So args is something that points to a character. And that's why the double pointer here. You can have double pointers. And this is where one way you see it is the analog of this thing here of the main function. This allows you to take in arguments from the command line. So let's see. Oh, yeah. So let's print F. And then we want to do arg square bracket. We want to do %s, say, and then arg square bracket 0 and arg square bracket 1. So let's do it like this. We have to have two. Okay, so we have two strings. Now, see, I've taken, this is an array. Each element in the array is a string. So this should be the first string. So it's something that points to us. So it should be %s, right? Because args is something that is an array of strings, not an array of characters, right? Let's see how this works, or if it works. Okay. What's the int argc? Well, a string in Java knows its length, right? It's an object that knows how long the string is. Whereas this is just an array. It doesn't know how long it is, but you might need to know how long this is if you wanted to know how many characters there were. So this tells you, argc tells you how long this array is. The program itself doesn't. This is like when you start a C program, the program that calls your program, which is the shell, fills in those numbers. So let's see if we can, this will be string array.c. And we'll see if we've made any errors here. Okay. Oh, yeah, because I didn't have what I didn't put in up here was what I needed here. I needed the include file. What it's saying is, the error here is that I have an implicit declaration of printf, which returns an int, but that's it's a warning, because, and you can see here it says likely we're supposed to include a header for printf, and it's telling you, well, that this is a function in this. There, so save that, and let's see if that fixes the warning. It does. So, well, that's the 0th. That's going to be the 0th item. Let's see if we do first command line argument. That's what this is called. All right, let's see if this works. Okay, so it printed off what was on the command line. See, dot string array. This was the 0. This was the arg square bracket 0 was the name of the program, and args of 1 was this one here. And we could also print out. Let's do %d and do argc. Just so you can see that should be 2, right? There's the 2 because there's 2 command line arguments. So we have an array of length 2. If we put we could put more arguments here, but then we'd have to have, we could make a little for loop that would print out all the command line arguments, and we can make the for loop run over argc items, and so you could put any number of command line arguments. And that's how a lot of controlling little programs in C works, is by putting options as command line arguments. Or if you want to copy 2 files, like you can, if I wanted to, like there's files here. Like if I wanted a copy of arrays1.c, I could, there's a C program called CP that copies, that would copy, say, arrays1.c to just some name like junk is here. Okay. Then if we wanted to, we could open this file, find the junk is here. There it is. Then you can see that I've got, and what was that? That was arrays1. So let's open arrays1.c. So you can see that they're the same program, because this doesn't have a .c extension. Excuse me, it's not treated as a source code file. Whereas this interprets the .c as the advice that this is, so it color codes it and as a file. One thing is on Java, on Windows and Macintosh operating systems, the operating system isn't really designed for use by programmers, so it allows you to do all kinds of things, like it tries to capitalize letters, like in Windows, oftentimes you'll write a file name and it will surreptitiously capitalize the first letter of the file name for you, which is a disaster for programmers, because you want to send this to a compiler, and so you have to have control of your file names, which is an important sort of feature of learning how to counteract that in the bad effects of your operating system. Which is good for users who aren't going to be programmers, but if you're going to be a programmer, you need to keep track of that. Okay, so there is everything about arrays. You can see the syntax is similar, but what's going on is a little different. It begins to diverge, say, when you have strings. So any questions before we go on to structs?
Not from here, but thank you.
Okay, so we will start over with a new structs, or sort of like primitive objects. Okay, so let's try to figure out how structs work. Okay, so a struct has a you have to give a definition of the struct. So it's sort of like there's a difference between declaring a struct, which is like specifying a class definition, and actually allocating space for the object. So let's say we have struct, let's say 2. 2 numbers, that's the name of the struct. And so it works like this. We have a semicolon at the end, and we can have int, well, no, let's just call it 2. But it's not, an array would have 2 numbers. This could have 2 numbers. Number, letter. We'll have to make it char star name. So it's going to have 3 things in it. So I packaged together 3 items of different types. Okay? A number, a letter, and a char star. They're all different, and they're all potentially different lengths. So what this is like a class definition with all public field variables, because there's nothing private about these field variables here. They're just fields in the struct, right? But and there's no methods. You can't associate methods with them. But they're the sort of the primeval ancestor of classes and objects, because you're packaging together items of different types. Okay, we have int main. Now we want to do our program where we want to declare a struct. Well, this struct is of type struct3. So if I want a variable of that type, I do struct3 sam, say. So now what this does is this declares sam to be, it's like an array name in which it's literally stands for this object. It's like saying int number. Numbers is a name of a memory cell, but it's not an address. It sort of represents the memory. This sam represents these three items. Okay, so we can also have a pointer to sam, but let's just deal with the struct initially first. Okay, well, how do we want to give values to these fields? So we could do sam dot number equals, say, 15. Okay, so you might recognize this dot as like when is something familiar for a field variable. When you access a field, you'd have object dot field variable here. So this is similar to that. And then you could do sam dot letter equals, let's say, just exclamation point. Okay. And then we could do sam dot name equals Diego. So why not? Okay. So there we've set the values for the three three fields in the struct, and then we could check whether or not they're actually printed out. The first one would be %d for number, %c for letter, and %s for the string. And this would be, we have to give sam dot number, sam dot letter, and sam dot name. Okay, so this is struct1 dot c, and then do gcc 1.c dash o struct1. Oh, I need to, maybe I can copy it from here. There, I left off the header file. Okay, so that works. And then, okay, and you can see it printed off 15 exclamation point in the name, so it works. So we've declared a struct. This is like a sort of class definition, which you declare the fields. This is like the constructor thing when this actually allocates space. This allocates space for the struct. Oh, and there's something interesting about structs in that oftentimes in C you need to know the sizes of things, because these types can be different sizes on different machines. So there's actually a size of function. So we can go here and do printf %d size of and we do size of Sam. We could also do size of struct3. It would be this, it would be the same thing. Well, we could see that we could do both of those. Why not? Size of Sam, size of struct3. We'll see. Okay, it did. Oh, yes. The problem is size of has a special formatting thing. It's sort of the Z. It's the U stands for unsigned. U is the Z is the Z from size of, and the U means unsigned because unlike Java, variables in C can be either signed or unsigned. In C, ints are always signed, but you can have an unsigned int where the bit pattern will be interpreted as entirely a positive number. So the analog would be in this LC3 that the 15th bit would not be a signed bit. It would just be the bit 15 of a positive number. So you could get more positive numbers. Okay, so let's see if that fixes this problem. And, because I have two of them, I have to do both of them as ZU. Let's see if that fixes the problem, and it does. So we can go and do this, and, well, I put size of 16, and then new line 6. So the point is that the size of Sam and the size of struct3 are both 16. Does that make sense? An int, what's the size of an int? Well, we could check that. Size of int is the number of bytes. So an int is 32 bits. That should be 4 bytes. Size of char equals 1. It should be 1 byte. This one's interesting. Star name, because what's the well, this is a 64-bit machine, right? So if an int is 32 bits, which is 4, so this should be 8, right? Well, but there's a problem here. Look at that. If I add these up, we can check this. Let's check this to sort of see if I add up 8 plus 1 plus 4, I have 15 bytes, but here I have 16. They're not the same. Printf, let's do percent ZU, percent ZU, and we're going to do, let's do them in order. Size of char, size of int, size of star name, and see if that, and we don't need this size of thing. That sort of messes up the pattern. Okay. Name undeclared. Oh, because it's not name, it's Sam.name. There. Okay. So the ones here are, wow, that's interesting. You see, there's these three. Size of char is 1. Size of int is 4, but size of name dot star name dot c. Oh, because I did star. That's what it points to, which is just a character. What I want is the size of the pointer, not what it points to is just a character, which is 1. Okay, so we want to try this again. There, 148, 148. That confirms this. Now let's make another struct here to see if we can play with this. Let's see. We'll have 4 things here. Let's do char letter long number 1, then say char say just another letter 2, and this will be letter 1, and then we have int number 2. Okay, so this should be size 1, right? This should be size 8. Long is long, a long int is going to be 64 bits, so that's 8 bytes. This should be 1, and this should be 4. So the total is 14, right? 8, 9, 10, 14. And maybe that's, let's see what printf size of struct 4. Somewhere I forgot the semicolon here, right? It needs a semicolon because somehow it's a declaration. Okay, there. Okay, well, look at that. We expected 14, we got 24. Why is that? So we expected 14, but we got almost 10 more bytes. So if we had an array, we can have an array of structs, right? So if we had 1,000 structs, we get 10,000 extra bytes, like 10 extra kilobytes of space being used. Now it turns out that I can change the order of these variables here to change the size of the struct. What's going on is something called padding, that because this is 8, it wants to put everything into blocks of 8. So this one is actually going to be 1 plus padding of 7, right? And this will be 1 plus 7. And this will be 4 plus 3, right? Well, I think, oh no, because I would only need, I need the 7 here, but I could put the 1 and the 4 together. This would be, I don't need this one. I can put both the 1 and the 4 in one memory cell, and this would be 5 plus 3, right? Plus 10 cells of padding equals 24. Because what's going on is, so the memory, the picture of the memory here is the following for this struct. What it does is going to have the first memory cell of 1 byte, right? Then it's going to have, oh, this is terrible. you're going to have one cell there, right? Then you're going to have 7 cells there. Then you're going to have, there's the 8 for this. Then the next one, you're going to have a 1 and a 4 and a 3. So this will be this will, this will be 1 byte, 7 bytes of padding. This is the 8 bytes. This is 1 byte. This is 4 bytes and 3 bytes of padding. This first one here is letter 1. This is number 1. Let's see. Oh, it's the other way. Yeah, this is letter 2, and that is number 2. So this way, what it's doing is it's not maximizing space on the hard disk, what it's or memory. It's maximizing the readability. So if I want just this character here, it's easier to read 64 bits at once, right? So it's going to read it as 64 bits, 64 bits, 64 bits. So it pads the variables together in this memory space. Knowing that, I can reorganize this. If you realize that, you can get the same field variables for 4to smart, which is, let's put, we want to cut this. We'll put those together because then they'll be next to each other. And then I'll put this, which is over here, and fix that. What did I do? Oh, I don't need this. I could have to redo the calculation now. So this is going to be 1 byte, 1 byte, 4 bytes. That's going to be 6. So I only need 2, right? So that's going to be, there's only 2 paddings. So this calculation will be, will be 14 plus 2 equals 6. He says 2 will be 16, right? So then if we, we're about out of time. Let me do this one last thing. We do this and we do the size for smart. We save this. See if we can compile it. There, and you can see here, 16, there's our 16. So that means we've saved 8 bytes. Well, I mean, that's not a big, if you have lots of space, who cares? The point is that the compiler chooses speed over saving of space. Some compilers might, if you choose optimization things, you can get compilers that will reorganize your field variables for you to reduce space. So there's anyway, but this is something about the hardware, about the memory space, that it changes depending on, like you wouldn't think that this uses more space than this. I mean, they're the same field variables, right? So you just write them any which way you want. Now, this is going to happen in Java and C, no matter, it's going to happen the same way, because this is how you'll get it in Java, everything's getting translated to by a compiler to run in machine language. And so this is sort of a machine language effect that you can see in Java, and C you can understand in the C language, but that you can't access or understand in Java at all. It's completely hidden. Anyway, so there you have a big story with structs. And we will, in the lab, we can just work on in the lab today the regex, right? Thanks. that's what I was looking for. We have the exercises on that, and also because we have the last demonstration this weekend, you might have questions about your concept check or whatever, because some of the questions you missed there would be similar versions on the demonstration. So you can sort of study for the weekend in the lab today. Any other questions? Feel free to head off.
Professor, I had a quick question that I'm having trouble with one of the pointer exercises.
Which one of the what?
One of the pointer exercises,
Okay.
the last one, printing to console 8.
Okay. Shall I bring it up? Let me see if I can bring it up.
Yeah, I can share my screen.
Okay, if you have it up, you're already there. Okay.
Yes. All right. Me.
Oh, let me